All right, so now that we have the basics done with the tiny data, so let's look at a regular data set, and we're going to use the accidents data set for this, an accident NN. It has selected variables. So let's go ahead and read the data in. We'll call it ACCDF, and the data file name is accidents NN. Okay. All right, let's look at the data here. So it has 3 predictors. Okay, first one is presence or absence of alcohol. 1 is present, 2 is absent. And then profile of roadway, okay, whether it is level road or not, 1 and 0. Then surface condition, and there are 5 of them. 1 for dry, 2 wet, 3 snow slush, 4 ice, and 9 unknown. And then a number of vehicles involved, okay, 1, 2, or 3 or 4, whatever. Then we have 3 possible values for the target, maximum severity of the accident, injury. Okay, so severity 0 is no injuries, 1 is injuries, 2 is fatal injuries. Okay, so those are the 3 possible values. Okay, now we have to, when you look at the data, you see this one is okay, it's 0 and 1, so it's not a big deal. But alcohol, presence or absence of alcohol, is 1 and 2. Okay, it should really be 0 or 1, right? So it should be, in other words, it should be a factor. And then surface condition is definitely a factor. There are 5 possible values, okay, and number of vehicles involved, that can be just left as is. Okay, so alcohol, so what we're going to do here, see, I'm going to follow the textbook. The textbook, they're going to leave the surface condition out. Okay, so alcohol, road profile, and number of vehicles involved. Those 3 are going to be the predictors. Okay, so we're going to select those variables. So we'll call it cell vars, okay, and we'll print the names and then copy paste the names. Okay, so you're going to do that. Okay, so the predictors alone, okay, and do a comma. We're not going to use surface condition. Okay. All right. Okay. So those are the selected variables. Now, before we partition the data, we want to create dummy variables for the selected variables. Okay. So first, we need to convert those into factors, and then the factors should be converted into dummy variables. Okay. So if it is a regular variable, then you don't need to convert them into factors. Okay. We are converting only those variables that are factors. Okay. Like presence of alcohol, yes or no, that's a factor. Okay. Profile of the road. Okay. So we have 1, 2, 3, or whatever. Those are not actual. The 1, 2, and 3 they are categories. So that's why we have to convert those into factors. The vehicles involved, actually we don't have to convert them into factor because it is the numerical values themselves have meaning. Okay. But I'm following the textbook here, I suppose. Or we could leave that out. But we need to, okay, let's go ahead. Let's go ahead and leave that out. See what happens. Okay. I really shouldn't be doing that, but I haven't tested this out early on. So now I'm going to show you how to convert several variables. So for example, let's go ahead and include surface condition also. Surface condition, so those are the 3 variables. Surface condition again is a factor variable, right? Because the numbers don't mean anything, it just points to a category. Okay, so now how do you convert these 3 variables into factors? So you can have 3 lines of code, right? So convert the first variable to factors, then convert the second variable to factor, then convert the third variable to factor. Okay. Which in this case is not a big deal, but if you have lots of variables to convert, you want this to be more efficient. Okay. So we can use more efficient code, and that is called lapply. So lapply will apply, okay, to the data that we specify. So acc.df. Now we want only the selected variables. Okay. And then, okay, we have to, okay, we'll come back to the second part just a second. And then you specify what should be applied to those columns. Okay. And we want the function as factor to be applied. Okay. So what this is going to do is going to go through this and apply this function to it. Okay. Now what we need to specify in between is, do we need to do this column wise or row wise? Okay. So you want, suppose if you want say maximum to be found or sum to be found, you want it to go row wise. Okay. But if you want these factors to be assigned for each column, so this operation has to be done column wise, and therefore we have to specify that as no, you don't, well, I'm sorry, I misspoke. Let's see whether this will work. Oh yeah, okay, so this is going to be column wise. lapply by itself is column wise. Sapply is where you have to specify. So lapply will convert those into factors. So we have list of, so lapply is list. So it creates a list of those 3. Okay. And then we can use, okay, we did this long back. If you do model matrix, okay, model matrix will create dummy variables for the factors. Okay, so you say, okay, so that's for everything. Okay, that data equal to ACC facts. Okay. We'll call it ACC facts for dummy variable. Okay. So now you have alcohol changed to zeros and ones, and you have the road profile, okay, and then the surface condition. They've all been converted into dummy variables. Okay. But it has the intercept, so I think 0 dot will, oh, I guess not. Okay. So we need to, okay, so we need only, we don't need the intercept, we need the rest of them, not the intercept, okay, as dummy variables. Okay. So what we have to do now is we have to combine, except for the intercept, the rest of them. Okay. So that would represent dummy variables for these 3 columns. Okay. And then we need the number of vehicles, okay, that we want to include in the data, and then of course the maximum severity. Okay. That's what's going to be our prepared data. Okay. So now we're setting up the data, and then we will do the partitioning. So now we have to select, okay, so after this, so we need to put them all together. So how do we do that? Okay, so let's see, ACC prepped data. Okay, so we can use cbind. So column wise we're going to bind, right? So first one will be ACC facts.dump, but we don't want the first column, so we need to remove that. So this part is going to bring us all of these columns, but not the intercept. Okay, and then we need that one. So we say that equal to, okay, and we need to get that from the original data. So that column should come in straight in as is. So that, okay. And then we need the maximum severity, so that's the name, and that again has to come from the same original data set. Okay. Okay, so here there is a problem, and that problem is because this is not a data frame. Okay, so this ACC facts.dump, okay, we did a model matrix. Model matrix will create a matrix for us. So we should have done, or I should have done, I should have converted that into a data frame. Then if you run, it will work. So everything is a data frame, so you can bind. So now let's examine the data, ACC prepped data. So we have alcohol, profile, surface conditions, then vehicle involved, then maximum severity. Okay. So what we did here is we selected the columns that were factors, okay, but coded as numerical values. So we converted them into factor variables with L apply. And once they have factors, we use model matrix to create dummy variables for them, and then save it as a data frame, and then we assembled all of these columns into one data set. Okay? Now once we have that, then we can partition into train and set seed 1, train rows, create data partition, ACC data maximum severity is our target, and we want, say, 60%, and list equal to false, and then we do train dot df equal to train rows or columns, and then valid dot df equal to train rows. Okay. So now we have prepared the data, and now we can do the analysis.